Welcome back to the Deep Dive. Today, we are taking a journey from a self-taught obsession in New Zealand right up to the cutting edge of orbital mechanics.
They are.
We're unpacking the incredible, relentless story of Rocket Lab. For so long, the space industry was all about these massive, government-backed rockets.
Right, the Titans.
But Rocket Lab's strategy was the complete opposite. They really focused on going small to achieve something huge.
That framing is so important because it gets to the very heart of their differentiation. Our mission today is to explore Rocket Lab's unique two-part strategy.
Okay.
First, how they carved out this specialized niche by offering fast, reliable, dedicated launches for small satellites. And second, how they leveraged that success to pivot into a full end-to-end space infrastructure provider. Someone who sells you the entire service, not just the ride.
And we've put together sources that really map out this whole evolution. The innovation behind their Electron rocket, the massive strategic leap into spacecraft components, and their newest gamble, the medium-lift Neutron.
It's a great story.
It is. If you want to understand how a startup successfully challenged the entrenched space industry giants, you really need to know this story.
Absolutely.
So let's unpack this journey, starting right at the beginning. 2006, with founder Peter Beck. He sets up shop in Auckland, New Zealand. But the key thing here is his background. He wasn't trained in the traditional aerospace industrial complex. Our sources paint him as a true propellant enthusiast, largely self-taught, building experimental hardware, things like homegrown rockets and even jetpacks.
And that intense, hands-on, problem-solving curiosity, that really became the company's absolute DNA. It let them approach the market without the baggage of decades of aerospace orthodoxy.
Oh, right.
And crucially, that curiosity landed in the perfect market context. In 2006, and for years after that, the private space industry was still pretty immature, and the small satellite market was, frankly, terrible.
And when you say terrible, you mean structurally inefficient.
Exactly. If you had a small payload, a CubeSat, or a small constellation satellite, you had two really bad options. You could wait, potentially years for a rideshare slot on a massive rocket.
That was cheap.
Cheap, but you had zero control over your launch schedule. Or maybe worse, you had no control over the final orbit. You were just, dropped off wherever the main customer was going.
Total bottleneck.
A crippling logistical bottleneck for this whole new small satellite economy. Beck's foundational idea was dedicated launch. Control over schedule, control over orbit.
That vision started translating into actual capability pretty quickly, though. The first big milestone comes just 3 years later, 2009, with the launch of the AT-1.
The ET-1 sounding rocket, yeah. It was just a simple suborbital flight, but the significance was immense.
How so?
It made Rocket Lab the first private company in the entire southern hemisphere to reach space.
Wow.
And that moment was critical because it proved capability to sophisticated investors. It wasn't just, a prototype in a shed anymore.
Right.
This quickly attracted serious venture capital.
From some big names.
Oh, yeah. You see early backing from major players like Khosla Ventures, Bessemer Venture Partners, and even a strategic investment from Lockheed Martin.
Which is a sign the establishment was starting to pay attention.
Exactly. And that capital gave them the resources to scale from, little sounding rockets to actual orbital vehicles.
But the U.S. market is the biggest prize in aerospace, especially for government contracts. That required a bit of a strategic shift, didn't it?
It did. Around 2013, they started planting a flag in the U.S., eventually setting up their headquarters in California. To really capture those major government and commercial contracts, they needed a physical U.S. presence.
Which brings us to their first major bet, the Electron rocket.
This is the core product of Rocket Lab's first era. It really cemented that strategy of going small on purpose.
Specialized for payloads up to what, about 300 kilograms to low Earth orbit?
Roughly, yeah. But what's often overlooked are the extreme engineering choices they made to hit their goals of high cadence and low cost.
Let's talk about the engines.
The Rutherford, that's where the innovation truly is. The Rutherford engine is revolutionary because it's an electric pump fed.
Okay, what does that actually mean?
Well, traditional rocket engines use these complex, massive gas generators, or staged combustion cycles, to drive turbopumps. Rutherford uses brushless electric motors powered by lithium polymer batteries. It's a completely different approach.
And why does that choice matter strategically? What's the benefit?
It just simplifies the plumbing dramatically. Fewer complex parts mean less weight, easier assembly, and critically, it's perfect for rapid manufacturing techniques like 3D printing.
Ah, so they could basically 3D print most of the
A
engine.
huge part of it, yes, which speeds up their production line immensely. And that's essential if you want to hit the high launch cadence they promise the market.
And pairing those engines with the Electron vehicle itself, our sources highlight it as one of the first fully carbon composite orbital rockets. Why is the material choice so important for a small launcher?
It's all about weight. Carbon composites are incredibly lightweight. For a small rocket, every single kilogram you save translates directly into added payload capacity. They had to maximize their payload-to-weight ratio to make the economics work.
So this advanced construction plus the simplified Rutherford engine.
That was their recipe for making frequent, dedicated launch affordable for small satellite operators.
But building the rocket was only half the strategy. The other half was getting away from, the congested traditional launch infrastructure.
Precisely. Rocket Lab committed to radical vertical integration. They didn't just build a rocket, they built their own private orbital launch site at Mahia Peninsula in New Zealand.
Launch Complex 1, LC-1.
And it became the world's first privately owned orbital launch range.
The power of that for you, the listener, really cannot be overstated. By controlling the rocket, the engines, and the schedule at their own launch complex, they could just bypass all the bureaucracy and logistical logjams.
Exactly. If a customer needed to launch in 2 weeks, Rocket Lab could genuinely offer that. They solved the agony of rideshare scheduling by owning the entire process.
That whole strategic bet had to be validated through actually flying, though.
Of course. After a couple of crucial early test flights in 2017 and early 2018, they had fun names, "It's a test," and still testing, they proved they could reach orbit.
And then they move fast.
Very fast. By late 2018, they were flying "It's business time," their first mission with paying customers, proving the model was viable.
And as their reliability grew, so did demand, especially from the U.S. government and defense customers. But those sensitive customers often require a domestic launch option.
Which is why we see the establishment of Launch Complex 2, LC2, at Wallops, Virginia.
That move really signaled they'd reached operational maturity, the shift to dual-hemisphere operations.
It wasn't just about New Zealand anymore, no. This flexibility allowed them, by the mid-2020s, to achieve an incredible operational cadence. We're talking 3 active pads, 2 in New Zealand, 1 in Virginia.
And that led to
A phenomenal 21 launches in a single year, all without failure. This cadence is what established Electron as the reliable workhorse of the small launch sector.
Okay, speaking of reliability and high volume, if you're launching that frequently, the cost of replacing the entire first stage every single time must become a massive burden.
A huge burden. And that's what drove their experiments with reusability starting around 2020.
I find their approach here fascinating because they tried something audacious and then, well, they walked it back.
It's a great example of engineering pragmatism. Initially, they attempted mid-air helicopter capture of the descending first stage.
Which was an amazing visual.
An amazing visual, and technically successful a couple of times, but it was just proving far too complex, too costly, and inherently unreliable to integrate into a high-cadence, fixed schedule operation.
So they pivoted?
They pivoted to the simpler, more scalable marine recovery method. They sacrificed the spectacle for sheer business efficacy.
It was a crucial, risk-mitigating decision aimed squarely at maintaining that high cadence above everything else.
Exactly. And the Electron platform showed flexibility in other ways, too. They created the HASTE configuration.
What's HASTE?
HASTE stands for Hypersonic Accelerator Suborbital Test Electron. It basically repurposed the Electron as a hypersonic testbed for suborbital defense and research missions.
So another revenue stream from the same core tech.
Another revenue stream, monetizing that proven technology in a completely different market.
Okay, so by the early 2020s, Rocket Lab is the undisputed leader in dedicated small launch. But around 2020 to 2022, they made a huge strategic decision to be more than just a launch provider. That's the second big bet.
And this is the critical pivot for their long-term survival. Launch services, no matter how reliable, can be financially lumpy.
Right. You get big bursts of revenue.
But it's not steady. Steady, predictable, high-margin income comes from the components, the hardware, and the persistent services you sell before and after the launch.
So they decided to build out a full space systems division.
They did. And to build this full stack, they started snapping up critical suppliers. Our sources list Sinclair Interplanetary, Solero, and Planetary Systems.
And it's not just a random shopping list. Why were those specific acquisitions so crucial?
They needed to control the entire supply chain and, critically, the quality of the most mission-critical components. Take Sinclair Interplanetary, they make reaction wheels.
Which control the satellite's orientation.
Exactly, it's stability. If Rocket Lab is going to guarantee the performance of a whole constellation, they can't risk a third-party component failing. Solero gave them solar cells power. Planetary Systems provided separation mechanisms, the critical hinges that deploy the satellite.
So instead of just launching the vehicle, they were building the vehicle, and the core product of this new division is the Photon bus.
Yes. The Photon bus is essentially a ready-made chassis, a flexible, small spacecraft platform that includes propulsion, guidance, power, everything.
So it saves customers a ton of time and money.
A massive amount. You skip the whole process of designing the basic satellite structure yourself. And this platform can support missions not just in low Earth orbit, but they can send missions into lunar space and even beyond.
That's the definition of the end-to-end space company term we keep hearing. So for you, the listener, trying to picture this, it means Rocket Lab can design your satellite, build the hardware in-house, integrate it onto their Photon bus, launch it on their own Electron rocket, and then even operate the mission for you.
They control the quality and timing of the entire pipeline. And this kind of expansion, it requires serious capital.
A lot of money.
So to fund all this, the company went public in 2021 via a SPAC merger with Vector Acquisition Corp, raising roughly $777 million.
The choice of a SPAC, a special purpose acquisition company, is interesting.
It really speaks to the velocity they needed. In 2021, the space industry was red hot, and the SPAC merger let them access a ton of capital much faster than a conventional IPO would have.
And they needed that funding for their third major bet.
Their biggest bet yet, the Neutron rocket.
Which is almost a contradiction of their original identity. Peter Beck, who is still founder, CEO, president, and CTO, is leading this charge. And Neutron takes Rocket Lab entirely out of that small launch bracket and into the medium lift market.
This is a colossal scaling difference, and it carries proportional risk. Electron handles 300 kilograms.
Right.
Neutron is designed to carry up to 13,000 kilograms to low Earth orbit in reusable mode.
13,000. That's a jump of over 40 times the capacity.
40 times? I mean, that's not incremental growth. That's a whole new engineering playbook.
So why risk such a massive leap? Why not just stick to their dominant small launch niche?
Because the biggest, most profitable market today is the mega constellation deployment market. Think Starlink competitors, Earth observation clusters, larger government satellites.
You need a bigger rocket for that.
You have to play in the medium lift class. Neutron is explicitly targeting the bulk deployment of these constellations while also enabling massive interplanetary missions. They aim to send payloads of about 1,500 kilograms to Mars or Venus.
And we're seeing dedicated infrastructure being built for this new phase. Where is Neutron set to launch from?
It'll launch from a dedicated pad at Wallops, Virginia. Ground was broken back in 2022, securing that vital U.S. launch site. Development is moving fast. We even have fun details, like the massive payload fairing that houses the satellites. It's nicknamed the Hungry Hippo.
Huh. That's a great detail that humanizes the heavy engineering. The timeline for Neutron is the critical next step. The first flight is currently expected around mid-2026.
And that's not just another product launch. It's the critical inflection point for the company's entire identity.
It really is.
If Neutron validates its reusable promise, Rocket Lab could become the only major player that reliably and affordably serves both the tailored 300-kilogram class with Electron and the high-volume 13,000-kilogram class with Neutron.
And they need that dual capability because the competitive landscape is just brutal. You have the heavy lift incumbents, giants like SpaceX dominating the top end, and the small launch segment is constantly crowded with new entrants.
Exactly. So their primary differentiation is no longer just, we launch small satellites. It's their focus on cadence, reliability, and above all, integration. They aim to be the partner that provides the full stack, the service wrapper.
The entire package.
The entire package, from manufacturing your reaction wheel to operating your satellite on orbit.
So if we connect this strategy to the bigger picture, this diversification is a huge stabilizer. By supplying the core infrastructure, the components, the buses, the services, they're positioning themselves as a picks and shovels provider.
That's a perfect way to put it. They make money regardless of which specific constellation succeeds because they provide the reliable tools everyone else needs to succeed.
That's the core takeaway. The evolution is just striking. From a lone founder obsessed with propulsion in New Zealand to a dual-hemisphere, multi-business public company.
They realized their mission opening access to space required more than just an innovative rocket. It required building the whole infrastructure around it.
It's an amazing journey from the tiny T-1 sounding rocket to the looming debut of the much larger Neutron. Rocket Lab's success depended on defining a small niche with Electron, but their long-term survival now rests entirely on successfully bridging that gap to the medium-lift market.
And that raises the final provocative thought for you to consider, the listener. What new markets and capabilities will be unlocked globally if Rocket Lab can successfully operate high-cadence, reliable services in both the 300-kilogram class and the 13,000-kilogram class simultaneously? If the logistics of space deployment become that flexible, what groundbreaking applications that we currently consider impossible might suddenly become economically viable? That's the frontier they are building toward.